Okay, so before I do this example, one of the things I want to do is I didn't draw the picture for this. And so if you want to, it's a good idea to make sure that you sketch the picture, the region that's being defined here. So one, that you see that all of the requirements of the rule are satisfied. Remember, they both have to be continuous and non-negative. That's obviously true if you look at the functions. And the one thing I'm thinking of is over this interval, f of x is greater than or equal to this one. So is that true? So you want to make sure that that's true. In this case it is, but again, sketch the graph and verify that that is the case because that's one of the conditions, right, that we're supposing. In this case it's fine, but again, sketch the graph, use it at your graphing calculator or do it on pen and paper and just verify that we're okay here. Okay? So, what are we going to do? Well, in this case here, the other thing too is that we know that this and this are both going to be above the x-axis. So, from 1 to 4, these are going to be bounded. Right? So we know, again, if I just sketch the graph, right, we know 1 over x does this, right? And we know x does that, right? And so these are both the same at 1, right? So this is where it begins. And so if we go to 4, again, I might as well just sketch it, okay? So here, obviously the region that we're interested in is in here. Now, 1 over x never reaches the x-axis, right? So we're going to have this gap here, this cavity. So this is the volume that we want to rotate, the area rather, the region that we want to rotate. Okay? So again, I guess, yeah, just to show you. Okay, so now we're going to have to use the washer method. If you understand the behaviors, then you don't have to sketch it. But again, if in doubt, sketch it out. Okay, so here we go. We're going to do the volume, right? So we know the formula. We're going to use the washer method. So we're going to go from A to B, pi times f of x squared minus g of x squared dx. And so now let's fill in what we know. So it's 1 to 4. I'm going to pull the pi out. And so this is going to be x squared minus 1 over x squared, because I'm squaring them, so I'm just going in and squaring them already. And this is dx. Okay? And again, just make sure that it was done right. So f of x squared minus g of x squared. And I pulled the power out, or the pi out. So now I'm going to integrate. So this becomes what? 1/3 x cubed minus what? Well, this is x to the negative half, right? So this will become what? Negative, right? Negative what? 1 over x, right? Because you increase by 1, which means this becomes a negative 1, and then you divide by the new power, which is negative 1. So actually this becomes a plus 1 over x. And this is evaluated from 1 to 4, right? And so now, guess what? Now we're going to go ahead and plug it in and evaluate this sucker. So this is going to be pi times, it's going to be evaluated at 4. So this is going to be 1/3 4 cubed plus 1 over 4 minus, now we're going to evaluate at 1/3 1 cubed minus 1 over 1. Okay? Okay, so what happens over here? This is going to be 64, right? 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. So we get 64 divided by 3. So this is going to equal pi times 64 thirds plus 1/4. This is going to be minus 1/3, right? So this is going to be minus 1/3 and then plus 1 because I distributed the subtraction across. And so now if you simplify this thing, what do you get? (81 pi over 4). Or 20 and 1/4 pi. And that's it. So here's one for you guys to try out. And as usual, let me know if you have any questions about the answer or if you get stuck. So find the volume of a solid of revolution formed by revolving the region bounded by the graphs of f of x equal to the square root of x, g of x equal to 1 over x over the interval from 1 to 3, and we're going to go around the x-axis. Okay, so that's the one I wanted you guys to try on your own. See if you get the correct answer. Okay, again, just use the formula and integrate and take your time, and you should do fine. Just most students, when they make the mistake, it's going to be in the algebra and the sign errors and the arithmetic. So again, just take your time. Until next time, you have a great day.